This is part two of the linear motion video. We did this in the last video. We're given a particle moving up and down the x-axis with this position. We determined its velocity and acceleration, and we mapped out its velocity, moving in the positive direction, negative direction, and positive direction. So this video, we're going to talk about distance. And distance depends on velocity and direction. So the first question is the net distance. Um, Well, the net distance is pretty simple because the net distance, it really, you don't care how many times it changes directions. Um, you just figure out where it started and subtract from it where it ended. So for net distance, you'll just take its position, and remember the position function is the y, and figure out its position at 3 and then subtract from it its position at -1, and that will give you net. So its position at 3, if you plug in 3 to this position equation, would be 3 cubed, which is 27, minus 6 times 9, plus 5, which is -22. So that's the position it's starting at. And then subtract from it its position at, or I'm sorry, that was the position that was ending at. Sorry, subtract from the position it's starting at, y of -1, which would be -1 minus 6, which is -7, plus 5, which is -2. So minus a -2. So -22 plus 2 is -20. So its net distance traveled was -20, which means from where it started to where it ended, it's 20 units below where it started because it's negative and you're moving up and down. So that's how you do net distance. That's pretty straightforward. So we had -1. I'm just checking my work. -7. Yeah, I think it's right. So the total distance is a little bit different because the total distance, you're going to have to measure every single time it changes directions to include on the total distance. So we're going up and maybe then down and up again. So you have to add up all those directions for total distance. So it's very important to understand when it changes directions. So we already did that. The velocity is tells you what directions it's going, and it changed directions at 0 and 4. So one way to do this is to map it out. Um, Figure out where you started, like what position you were at -1, which we said was -2. And then we're going to end up at y equals 3. But it's important to understand, well, where are we changing directions between that? And according to our velocity, we change directions at 0. So that's a key spot. So I'm going to figure out where I was at 0. So that's just y of 0. And that equals 5. 0 plus 0 plus 5. And then figure out where we are at the end. So we changed directions at 0, and then we're going the other direction until we get to 3. We're at position -22, according to this. So your total distance would be, add them all up, from -2 to 5, it's a total distance of 7. And then from 5 to -22, that is a total distance of 27, because you have to go from 5 to 0 and then to -22. So that's 5 plus 22. So your total distance is 34. So a quick calculator way to do this, and we haven't really studied integrals, but our calculator will do them. And since it's the next thing we're going to do, I'm going to share that with you. To determine net distance, a real quick way is to just integrate the velocity from where you're starting to where you're ending. So that's, and we'll say this is dt. You'll see that in a minute, but you don't really have to understand that just yet, but know that you could do it because this is how easy it is on the calculator. If you plug in your velocity, which I just did, this is our velocity, 3t squared minus 12t, and second calc integral, that's 7. I'm going to zoom 6. Second calc integral. I'm going to go from -1, so I'm going to type, when it says lower limit, -1, enter. Upper limit will be 3, enter. And it gives me the answer of -20. So that was a real quick way to get that -20. So you might be thinking, well, that wasn't hard to get -20 to begin with. All we did was plug in numbers. But the net distance, though, was a little bit more complicated. The net distance is that same integral if we're going from -1 to 3, but the speed or the absolute value of the velocity. So to do that on the calculator, one way you can do it is I'm going to go into y equals. I'm going to hit absolute value. And I'm going to go alpha, I think it's trace, yes. Type in y1, so I don't have to type the function in again. So now it's going to do the absolute value of y1. I'm going to turn off y1 and then just graph the absolute value. And the absolute value looks like it should. Anything that was below the x-axis is going to be above. And now I'm going to hit second calc integral again, so second calc 7. And I'm going to go from -1 to 3 again, so -1, enter for the lower limit, 3 for the upper limit, and it gives me a final answer of positive 34, which we knew. So that was a really quick way to do it. You're going to be studying about integrals very shortly, so it's not a bad habit or to get into right now, being able to do this on your calculator. So that's it for linear motion. I'll see you on the next video.